Hey everybody, in this video we're going to be using the unit circle. Probably should call this understanding the unit circle because we're going to do a little bit more about how the unit circle works versus how to use it necessarily with certain values. So it's more of a, this video is really going to really focus on more of an understanding of the unit circle and the relationships within the unit circle. So when we begin, we always talk about Sohcahtoa, and Sohcahtoa is that phrase that we use to remember sine, cosine, and tangent. And then the OH's and the A's are all talking about opposite sides, hypotenuses, and adjacent sides. So if we talk about that's going to say our sine value is equal to opposite over hypotenuse. So that's where the O for the opposite, the H for the hypotenuse. The ka part is cosine, which is adjacent over hypotenuse, and the toa is our tangent, which is opposite over adjacent. So those are the real basic ideas of our sine, cosine, and tangent when we're using it in terms of a right triangle. And that right triangle comes into play with our unit circle because we have some angle theta here, and we might have that go to our cosine value and our sine value. So we say that because our cosine is representing our x value and our sine is representing our y value. Now how do we know that these things are cosine is x and sine is y? Well, if we're focusing on this angle theta and we were to drop in an altitude or a height of a triangle, we make a right triangle there. The right triangle going with the vertical line and the x-axis. Then we know that the opposite side of theta is going to be our y, so our sine value is going to be y over our hypotenuse. And again, our hypotenuse is a value of 1 on the unit circle, so the sine value is just whatever y is. And then the x-axis, or going from the origin to the vertical line, is our x value, so that's our cosine is going to be equal to the x value. So cosine theta is the same as our x because, again, our hypotenuse is 1. So what about tangent? Well, tangent is going to be our y over our x because it's opposite over adjacent. So we could just take whatever the coordinates are for that point and do y over x, and we could get our tangent value. Or we can sometimes say just sine over cosine. Either one, depending on the information you're given, you can use or use for tangent or call tangent, sine over cosine or y over x. So let's look at it when we go a little bit further. So now we're looking at this angle in the second quadrant being theta, so it's kind of a mirror image of the quadrant 1 angle. And if we were to go over a mirror image there, then our x and y's would be almost the same, but the x is going to be negative because we're in the negative quadrant there, and positive for our y because it's the positive portion of the y quadrant in quadrant 2. If we were to go a mirror image below that, then we would have a negative x and a negative y. And if we would go one more mirror image or reflecting across again into the fourth quadrant for theta, then we're going to have x and negative y. So let's look at an example. So if let's say we've got 30 degrees here. So I'm not going to put in values necessarily, but let's just kind of blow this out so we can see kind of how this is working with some numbers. So if this is 30 degrees, if I did another line over here, a mirror image, these two things would be equal distance apart. So we've got 30 degrees in quadrant 1, we've got 30 degrees in quadrant 2. So if we were looking at quadrant 1 and we called this x and y, then on the other side we would have negative x, negative y. And what we tend to say is when we're talking about our angles, we're going around from the x-axis around in an anti-clockwise or a counterclockwise direction. So we've actually gone not 30 degrees in quadrant 2, but we've gone a total of 150 degrees because we start at that positive x-axis and go anti-clockwise. So the theta values, they look the same, but what we're actually doing is our theta for the purple would be 150, and the theta for the red in quadrant 1 is 30 degrees. So we have to be careful when I'm saying this because I'm just using the circle on the left just to kind of show that mirror image relationship. But when we're actually talking about an angle measurement, we're talking about 150 degrees, like in the circle on the right. So we can say that sine theta is equal to 180 minus theta. Because if we look at this, 180 degrees is going to be a straight line. So we take the whole x-axis, we subtract out what theta is, 30 degrees, and we have our 150 degrees. And we can see that the sine values, the y values, are going to be the same. The cosine values, though, are going to be opposite. So it's going to be a negative value. So again, our theta is 30 degrees in quadrant 1. And our negative cosine is going to be 180 degrees minus that 30 degrees. So that gives us that mirror image, and we're looking at 150 degrees, but we've got an opposite value, or a negative value for x. So that's a relationship that we have there. If we were to go backwards 30 degrees, go down where the green is at, we're actually going in a negative direction. So if we're going clockwise, we're going in a negative direction. So it's kind of backwards. It's a little strange that clockwise is considered backwards, but that's how it works with the unit circle. So here our x and y values are still going to follow the same ideas of the different quadrants. We still have a positive x and a negative y because we're in a positive x portion of the Cartesian plane and a negative y, or negative portion for the y values. So we still would match up whether we went around in an anti-clockwise or in a clockwise, but if we lined up where we had our points lined up with each other, then we would still have just the positive x and the negative y. And lastly, in quadrant 3, before I get to quadrant 3, so we can say about our cosine there, that our cosine is going to be a negative theta. So cosine of theta is going to also equal cosine of your negative theta. So the same degrees going in the opposite direction. You get the same value. Okay, so now quadrant 3. So if we've got our 30 degrees there, then we're going to have our negative x and negative y, because in quadrant 3 both values are negative. So what about tangent? What do we do with tangent theta? Well, tangent is going to be our sine over our cosine. It's our y over our x. So let's look at this. So if we got y over x, that's on the red line in quadrant 1. But if we notice, that's also following that same line going down into quadrant 3. And that's equal, the values are going to be equal because the negatives cancel each other out. So y over x in quadrant 1 is going to equal the negative y over the negative x in quadrant 3 if we're, again, doing these mirror images. And similarly, if we look at y over negative x in quadrant 2, that's going to be the same as negative y over positive x in quadrant 4. So slightly different, but our tangent theta then is going to be equal to 180 plus theta. So again, look, at quadrant 1 we've moved 30 degrees, and then if we add another 180 degrees to get to the orange line in quadrant 3, we've got the same value. Similarly, if we go into quadrant 2, if we follow that 150 degrees, that purple line, and then we added 180 to that to get to the green line, then we would still have the same value. So this is just, again, kind of expanding on that identity idea. But it's a 180 plus theta instead of minus theta, like with the sine and cosine. All right, so then what about our degrees versus radians? So we know that we start at 0 degrees at the x-axis, and we go around 360 degrees in a full circle. We also go around 2 pi, going around the full circumference of the circle with a radius of 1. That's just your basic circumference formula. Circumference equals 2 pi r, and our r is 1 here. So full circle is 2 pi. So what about at 180 degrees? Well, that's half of 360, so that's going to be half of 2 pi, so that will just be pi. And what about 90 degrees? Well, 90 degrees is half of 180, so 90 degrees when we're looking at radians is going to be half of pi over 2. And then in between there, we've got, in between 0 and 90, we have our most common angles and triangles and radian measurements, and that's going to start with 45, and then we have 2 more that we'll look at. But 45 again is half of 90, so that's half of pi over 2, which is going to be pi over 4. And our other 2 most common triangles are our 30, 60, 90 triangles, so those would be the other ones we're looking at. So the radian measurements for 30 degrees, well, 30 degrees is 1/3 of your of that quadrant, quadrant 1. So it's 1/3 of pi over 2, 1/3 of the 90 degrees. So that measurement is going to be pi over 6. And 60 degrees is 2/3 of 90 degrees, or 2/3 of pi over 2. When we start simplifying, our 2's knock out and we're left with a measurement of pi over 3. So these are the main things to really remember. These, what's that, 1, 2, 3, 4, 5, 6, 7 measurements are the real key ones to remember. All the ones in between these measurements, between 90 and 180 and 180 and 360, those will all be similar in relations, but we'll get into those in another video. So, but we can say that sine is also equal to pi minus theta, which is basically the same as 180 minus theta. All right, and then so the last thing we have is this identity sine squared plus cosine squared equals 1. So that's saying the value of sine theta, whatever that is, if you square it, plus the value of cosine theta, whatever that is, and square it, then you're going to end up with a result of 1. And that's because we're using right triangles to build this unit circle. So it's just like the Pythagorean theorem. Sine squared plus cosine squared equals 1 is saying a squared plus b squared equals c squared. Just c squared is always going to be 1. So one final identity kind of when you're working with the unit circle. Okay, so let's look at an example real quick. So we're going to find 3 other angles for the following measurements. For the same values, or that have the same values as sine of 35 degrees and tangent of 35 degrees. Okay, so we've got a circle here, and we'll just say that this is 35 degrees. So sine of 35 degrees, what's another one that's going to match based on what we put up above? Well, we could keep on going all the way around to the second quadrant, and we know that that will give us another value. So that'd be sine of 180 minus 35, which is sine of 145. So that's our first of the 3 other angles. Now those are the only 2 where sine is the same, where they're both positive y. So we have to find other ways to get back to these 2 values, because all the other ones in quadrants 3 and 4 are going to be negative. So if we go backwards, we can go back the other way, and we go 180 degrees, and then that little bit which is the same thing as our theta. And so that would be sine of negative 180 degrees, and then another negative 35 degrees. So we end up with a sine of negative 215. And if we continue this circle from our negative 215 around to our original line, then we get sine of negative 360 plus our 35 degrees. Or you can always say negative 215 plus another negative 145. Either way, they'll both come out to a negative 325, which is your final of the 3 for sine 35 degrees. All right, what about tangent then? So tangent, we've got our same line here. We know that tangent of 35 degrees, and we have to find the opposite side of this. So we're going to use that 180 idea that we did up above. So tangent of 35 degrees is going to be equal to tangent of 180 plus 35. So that's going to be the same as tangent of 215 degrees, which is the first of our 3. Then if we go around backwards, we went back negative 360 plus 215. So I looked at the positive angle going all the way around to the dotted line, which is 215 degrees, and I basically subtracted that or added that to the negative value of 360 going backwards. So that's how I got the negative 360 plus 215. Because remember, I'm starting from the x-axis. So that simplifies to negative 145 degrees. So that's our second value of the 3 that we're looking for. So then the only other thing that we need to do is get back to the original origin, or not the origin, but the original line that we started with. So we'd have to go tangent of negative 360 plus the original 35 to get us back there. So negative 360 going all the way around the circle, but then kind of going backwards or going the right direction with our positive 35. And that gives us a negative 325. So that's our last angle there. So hopefully this helps kind of get some of those relationships on how the mirror images and how these things kind of work as you're looking across quadrants. We'll get into radians more in other videos, and the unit circle, and also the values that apply to these specific angles, the 30, 45, 60, 90, and so on. So that's it for this video, and we'll talk to you in the next one.